Good morning. Sorry this post is coming up late. I had an issue trying to get the screen to share something, so I had to record this whole thing again. Um, so our lesson for today is molecular shapes, and it's exactly what you think it is, the shape that a molecule takes. So the first shape that we have is linear. All right. Linear, exactly as it sounds. Linear is a straight line. Now, with this straight line, if you only have two atoms, it has to be linear. All right, so if there's only two atoms, it has to be linear. It can be more. But if it's two atoms, it's definitely linear. Sometimes if the central atoms are linear, the whole thing is going to be linear. All right. So what we have with this, an example might be hydrochloric acid, which was HCl. They're bonded right here, and that is a straight line. So if I were to just draw it using circles, that's what it would look like. Okay. So linear can be a single bond. Linear can be a double bond. Linear can be a triple bond. And linear can be multiple atoms. Like carbon dioxide is a linear molecule. It's a straight line. It's 180 degrees. So those unshared pairs of electrons have pushed these atoms as far away as they can. All right. The next style that we have is bent. Bent is something that's going to look approximately 90 degrees. All right, so it's going to look like you've bent your elbow. All right, a great example of a bent molecule. Typically, it's with three atoms. And an example of this is water, H2O. So oxygen has its 6 valence electrons, and it has a hydrogen attaching here and a hydrogen attaching here. So if I take away the symbols and I take away the dots, here's that one H, here's the O, here's the other H. So your 90 degrees is right here. It might be pushed a little bit further than 90, but it's approximately 90 degrees. So it looks like this. Okay. Our next shape is trigonal or trigonal, and this uses the prefix tri, which means three. So it's one central atom, and it has three atoms bonded to it. So one atom in the middle and then three around it. An example of this is ammonia, NH3. So here is nitrogen, and nitrogen is the central atom, and it has three coming off of it. So if I were to draw it, here's my central atom, here's my nitrogen, and 1, 2, 3. Okay. So that's what trigonal looks like. Here's your central with three coming off of it, and that's what makes it trigonal. All right. The last shape we have is tetrahedral. So we're going off of the prefix tetra. Tetra means 4. So tetra is one central atom with 4 atoms bonded to it. An example of tetrahedral is methane. CH4 is methane. So you have carbon in the middle, and carbon has those 4 valence electrons, and it's going to bond to 4 hydrogens. All right. And so carbon is your central atom, and then you have the 4 coming off of it. And so it kind of makes like a little pyramid with like one like little antenna thing sticking up off of it. So there's 1, 2, 3, 4. And that's how you get tetra. So even though there's 5 molecules, there are 3 around it. All right, so those are the 4 shapes. There are more than 4 shapes. There's, trigonal, bipyramidal. There's octahedral, but these are the 4 that we're going to be concerned about. The basic molecule shapes: linear, bent, trigonal, tetrahedral. 2 other vocab words that we're going to discuss today are polar versus nonpolar. All right. And this has to do with the symmetry of the molecule in reference to valence electrons. If something is polar, there is no symmetry. Right? It's not equal. There's no mirror image. I always tell the class to think of the phrase, polar bears don't share. All right, polar bears don't share. There's not going to be this equal, nice sharing of molecules. Nonpolar is going to look symmetrical. All right, that word symmetrical. So let me give you an example. For a linear molecule that we did HCl. So we had HCl. HCl is a polar molecule. If you look, Cl has 3 pairs of valence electrons, 3 unshared pairs. Hydrogen has none. It's unequal. So this is an example of a polar molecule. An example of nonpolar would be oxygen. All right, so oxygen is double bonded to itself. There's 4 pairs of unshared pairs. There's 4 unshared pairs. It's even. Each has 2 unshared pairs, and there's a double bond. It's symmetrical. It's even. It's a mirror image. So that's nonpolar. Okay, I'm going to draw one, and I want you to tell me if it's polar or nonpolar. All right, so we did methane. So let me make it look a little bit better. Okay, so take a look at methane. Think to yourself, does it look even or not even? It's even because there are no unshared pairs. I could like take a mirror and slice it. I could put that mirror anywhere and it would look symmetrical. So this is non-polar. Okay, this is a non-polar molecule. So that's something that you're going to practice today too. So the website or the assignment that you're going to use is the website that we used last week. So this is the assignment that's going to be posted up on Google Classroom. You're going to be using the Making Molecules site, okay? And you're going to click Molecular Builder. All right, click anywhere to continue. And Friday's assignment is you had to go through this list on Molecule Builder. But what you're going to do today is you're going to click free experiment. Okay, so you're going to click free experiment. All right, so you're going to click on the doc that's assigned today. It says molecule free builder. And you're going to fill out the chart. So the first one that you have to fill out is H2. And what you're going to do is you're going to go to the Making Molecules site, and this lets you kind of free build. So it's H2, so you would grab 2 H's. I don't know why it's not doing that. All right, hold on. I ran into this problem. Okay, so you're going to go to the assignment, the H2, and then you're going to click on the Making Molecules site. All right, so what you would do is you're going to go to Free Experiment, and you're going to drag out what you need. So we have H2. So you're going to take an H, and it says H2, so you're going to drag another H. You're going to build it just like you did on Friday by connecting the valence electrons. To see if you did it right, you're going to go to the green check. It says check answer. And it'll tell you, yeah, all the electrons have been bonded. All right, continue. So it says molecular shape. You would type in the shape. Well, it's a straight line, so it's linear. Bonds present. All right, so go back and look. Well, there's one line connecting the two. So there's one single bond. Are there any unshared pairs? No, there are no unshared pairs. So you would type none, don't leave it blank. And then polar or nonpolar, does it look even on both sides? Well, neither have any unshared pairs, so yeah, it is even. So even is nonpolar. And that's what you would do for each one, okay? When you need to go to the next one, you can hit a couple things. You can clear all atoms. Lets you say, yeah, I want to clear it. All right, so you're going to drag out like whatever you need. All right, so you're going to click on it, click, drag, click, drag. And then essentially, you're just going to put stuff together based on the formula that I have written here. So you're going to use this as a guide as to what you're going to drag out. All right. If you have any questions, please, I'll be on email all day. Don't hesitate to email me.